بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضة لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة الديناميكا وهو تابع طاقة الحركة. طبعا kinetic energy اللي هي its symbol T equal half mv square. مهم جدا نعرف طاقة الحركة الجسم بالنسبة للجسم اما يتحرك من مكان إلى مكان. Welcome my dear student in our math program for second 3. Today we are taking new lesson in dynamic subject. It's called Flow of Kinetic Energy. My dear student, look at introduction about flow of kinetic energy. My dear student, know that the change of kinetic energy of particle between two times instance equals T minus T naught. At the first, my dear student, kinetic energy equal half mv square. It's symbol T. By using, we have 2 times instant, we use T minus T naught equal half m multiply v square minus u square. Number 2, the change of kinetic energy due to collision between two bodies. The change of the kinetic energy due to collision between two bodies. If the two bodies as inclusion between them, then we deduce a change of kinetic energy equals kinetic energy after collision minus kinetic energy before collision. Number 3, the lost kinetic energy due to collision between two bodies equals kinetic energy before collision minus kinetic energy after collision. Number 4, what dot or times second equal Newton dot meter equals joule. We know that joule equal Newton times meter. Also, kinetic energy, it's measured by watt dot second equal Newton dot meter. Then we join between Newton dot meter, this is the work done. Newton force, meter displacement equals joule. This is the unit of the work, joule or edge. We know that joule equal Newton times meter. Newton times meter equal watt dot second. Kilowatt dot hour. Kilowatt equal 1000. We convert from hour to second equals 6 times 60. Then when convert from kilometer hours to watt second, we multiply 10 power 5 times 36 or 36 times 10 power 5 joule. My dear student, now we are translate to important example. A ball of mass 200 gram fell vertically down from height 6.4 meter on horizontal ground. It hits the ground and rebounded vertically upwards to height 2.5 meter. Calculate kinetic energy of the ball before hitting the ground directly. Number 2, find kinetic energy of the ball after hitting the ground directly. Number 3, change in kinetic energy of the ball due to impact with the ground. Solution. My dear student, we have a ball which has mass. This ball is filled from height to the ground and impact of the ground. The required, find the kinetic energy before impact the ground. What you need? We need the velocity to multiply v square. V square times m times half equal kinetic energy before the pole impacts the ground. After impact the ground, after rebounded, the pole is rebounded. When impact the ground, the pole is rebounded up for height or distance or displacement. We need know the velocity. By using the velocity square times m times half, we find kinetic energy after impact. After that, change of the kinetic energy before and after collision, or before and after impact the ground. What is the change of kinetic energy? My dear student, this example is very important to find three important requirements. What is the kinetic energy before impact the ground? What is the kinetic energy after impact the ground? What is the change of kinetic energy? My dear student, look at the solution. My dear student, look at in the opposite figure. The pole is red pole. Look at, in this case of falling, we know that V square equals V naught square plus 2GS. The required how to find the velocity. The pole is fall from 6.4 meter and G equals 9.8. Gravity force S equals 6.4. V naught or V1 equals 0. Why? Because, my dear student, the pole, when pole is fall down, then the initial velocity or V naught equals 0. By using the third rule of motion, V square equal V naught square plus 2GS, then V1 square equals 0 plus 2 times 9.8 times 6.4 equals 125.44. Therefore, by using square root, the velocity which the pole before impact the ground is 11.2 meter per second. The kinetic energy before impact with the ground directly equals T1 equal half mv1 squared. What is the value of m1? 0.2. V 11.2 squared. Then the kinetic energy before impact the ground is 12.544 joule. Remember, my dear student, when the pole fall, impact of the ground and rebounding, look at the opposite figure. 2.5 meter its height. Therefore, when the pole rebounded by 2.5 meter, then reach to maximum height. What you mean maximum height? Excellent student, V equals 0. Then, my dear student, in this case of rebounded, also V squared equal V naught square minus 2GS. Why minus? Because the motion is up. By using gravity force, G equal minus or negative. V square equal V naught square minus 2GS. Therefore, my dear student, what is the initial velocity, or what is the velocity when the pole moves at after impact? This is V2. V final equals 0. S equals 2.5. G equals 9.8. Therefore, by using calculator to can calculate V2 square equal 49, then V equals 7. V2 equals 7 meter per second. This is the velocity of the pole after impact the ground. What is the kinetic energy? Excellent student, have mv squared. Kinetic energy after the impact with the ground directly equals T2 half mv squared. Half times 0.2 times 7 power 2, answer is 4.9 joule. Therefore, this kinetic energy after impact. My dear student, what is the change in the kinetic energy due to impact? This rule. What is the rule? Kinetic energy after impact minus kinetic energy before impact. Look at, my dear student. We have, in this case, two kinetic energy. The first kinetic energy before impact with velocity and mass is constant. But after impact, velocity is a change. We find the value of the velocity and mass is constant to find the value of T2. Then change of kinetic energy equals T2 minus T1 equals 4.9 minus 12.544 equals negative 7.644 joules. Then this example very important in our life. If two bodies impact this collision, there is two kinetic energy. We have the first kinetic energy before impact. We have second kinetic energy after impact. We calculate change of kinetic energy by using the kinetic energy after impact minus kinetic energy before impact. My dear student, when we find the lost kinetic energy, excellent student, we replace T1 minus T2. Why? Because the lost kinetic energy equals T1 minus T2. What do you mean? Yes, the lost kinetic energy of two bodies equals kinetic energy before impact minus kinetic energy after impact. In this case, my dear student, the change of kinetic energy equals kinetic energy after impact minus kinetic energy before impact equals negative 7.644 joules. Another example. Body of mass 400 gram is projected with velocity of magnitude 280 centimeter per second on the line of the greatest slope of smooth plane inclined to horizontal at an angle with sine 1/20 upwards. Find the kinetic energy of the body after 8 seconds from the instant of its projection and change on its kinetic energy. Solution. My dear student, suppose C unit vector direction projection V0 280 centimeter per second. Acceleration in this case equal negative g sine theta, negative 980. Why? Because in gram, mass in gram, g in centimeter, sin theta 1/20 equals negative 49 centimeter per second. V0 208 centimeters is velocity. acceleration negative 49. Since, my dear student, V equal V naught plus AT, the first rule. By substitution, about V naught equals 280 and acceleration times t equal 392, velocity equals negative 111 centimeter per second. Therefore, kinetic energy bodies after 8 seconds, my dear student, T equals half mv square. In this case, m equal 400 gram, v square, v equals 122 for all power 2. Therefore, answer is 2,508,800 erg. In this case, my dear student, kinetic energy have mv square. What is the velocity? Velocity equals 122. By using rule, t equals half mv square, answer is 2,508,800 erg. The kinetic energy of the body at the instant of projection, T naught equals half mv square. V naught square 280. V naught square 280 square. T naught equal half times 400 times 280 square. Therefore, the kinetic energy of the body at an instant of projection equals what? 15,680,000 erg. Since, what is the change of kinetic energy of the body? Equals change of the kinetic, this rule, equal kinetic energy after projection minus kinetic energy before projection. T2 minus T1. Answer is kinetic change of kinetic energy of the body subtract 25 or 2,508,800 minus 15,680,000 equals what? Equals 13,171,200 erg. Another example. A sphere of mass 3 kilogram moves on straight line on a smooth horizontal plane with velocity 210 meter per second. It collides another sphere of mass half kilogram. At rest, they formed one body. After collision, we have two spheres. Two spheres are collides. The first with the second became one body after collision. What is there required? Find the common velocity after collision directly. Then calculate the lost kinetic energy due to collision. If the common body moved under effect of constant resistance, make it at rest after covering distance 2 and 4/7 meter. Calculate the magnitude of this resistance in gram watt. solution. My dear student, we know that sum of M1 V1 plus sum of kinetic energy before collision equals sum of kinetic energy after collision. M1 V1, this rule very important rules. M1 V1 plus M2 V2 equals M1 plus M2 V dash. This rule is very important if we have two spheres moves, each one with velocity different on the other. After collision, we know that we have common velocity and two bodies became one body, M1 plus M2. Then we know that M1 V1 plus M2 V2 equals M1 plus M2 times V dash. What is the V dash? The common velocity. Then we deduce that when two bodies are moving and collides with other, then the kinetic energy before collision equal kinetic energy after collision. Kinetic energy before collision M1 V1 plus M2 V2. Kinetic energy after collision equals M1 plus M2 inside bracket times V dash. Don't forget, V dash is the common velocity after collision. My dear student, look at the solution of this example. We know that M1 V1 plus M2 V2 equals M1 plus M2 inside bracket V dash. Don't forget, V dash is the common velocity. Then M1 3, V1 210, M2 half, V2 equals 0, equals sum M1 plus M2 3.5 V dash. The common velocity V dash equals 180 centimeter per second. Therefore, kinetic energy before collision equal half M1 V1 square plus half M2 V2 square before collision equals half times 3000 times 200 power 2 plus half times 500 times 0 for all power 2 equals 6.615 times 10 power 7 erg. Kinetic energy after collision equal half mv square, half times 3500 times 180 power 2 equal 5.67 times 10 power 7 erg. Therefore, lost kinetic energy equals what? Excellent student. Lost kinetic energy equal kinetic energy after collision minus or excellent student. The lost kinetic energy equals what? Kinetic energy before collision minus kinetic energy after collision. The lost kinetic energy before minus after, but change of kinetic energy after minus before. Don't forget, my dear student, lost kinetic energy before minus after, but change of kinetic energy after minus before. Then the lost kinetic energy 6.615 times 10 power 7 minus 5.67 times 10 power 7 equals 0.945 times 10 power 7 erg. With respect to the motion of the common body after collision, since v square equal v naught square plus 2as by substitution, therefore 0 equals 180 power 2 plus 2 times 8 times 1800 over 7. Therefore, the value of A equal negative 63 centimeter per second square. Since, my dear student, resistance negative R equals MA, negative R equals 3500 times negative 63 R equals 220,500 dying. My dear student, by the end of the lesson, we know that change of kinetic energy after collision minus change of kinetic energy before collision is very important. If the lost kinetic energy equal kinetic energy before minus kinetic energy after collision, but the change of kinetic energy, we know that equals kinetic energy after collision minus kinetic energy before collision. And we know that if the two bodies are collides and have the common body with the common velocity, we know that m1v1 plus m2v2 equals m1 plus m2 inside bracket times v dash. V dash represent common velocity after collision. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.